Hello, students. I'm going to have you grade your own gravity graphing assignment by using this video. So I wanted you to create two graphs, one about the relationship between distance and gravity, the other about the relationship between mass and gravity. We're going to start with a graph about distance and gravity, the relationship between distance and gravity. I provided the data for you here and a space for you to create the graph down here. Okay, so when you're making these graphs, make sure you go through the 7 components of a good graph. The first thing we need to do is choose the best type of graph to tell the story of the data. Since we are looking at relationships, we're going to choose a scatter plot. The next thing we need to do is we need to draw the axes. Okay, now I'm going to use the outside edge of the this side and this side of the graph paper, so you don't actually have to draw those in. You could just use what's already there for you. If you were going to go into the graph paper at all, you'd want to get out a ruler and make those nice lines for your axes, okay? But I'm going to put the y-axis here and the x-axis here and just use that outside edge of that graph paper. Now, you need to use consistent intervals in between the numbers on the axes, but the first thing I want you to do is figure out what goes on which axis, okay? So the dependent variable always goes onto the y. I'm going to write that over here. Dependent variable. This is a good best practice. And our independent variable is going to go down here on the x. So I'm going to write that just to remind us, independent. Okay. Put a box around that to stay organized. Okay, now ask yourself, in this situation, does the force of gravity depend on distance, or does distance depend on the force of gravity? In this situation, the force of gravity is going to depend on distance. So our force of gravity will go here on the y-axis for the dependent variable, and distance will go down on the x. So let's label those. Let's just start with that. That way we're nice and organized. So I'm going to write force of gravity over here, force of gravity, and I'm going to include my units. My units are meters per second squared. That's provided for you here. I know that seems like a weird unit. That's a unit of acceleration. We can talk about what that means another day. Distance is going to go down on the x-axis, and our units for distance is going to be meters right here. So I'm going to write that down here. We have distance in meters. Now you need to figure out, we're on step 3, those best consistent intervals that go on the axes, okay? So I like to write down my range. We're going to start over here with what goes on the x-axis, the distance. Let's write down our range for the x-axis. And it looks like we're going to go from 0 to 10,000. So 0 to 10,000. Okay? Now, a quick workaround to make this easier on yourself is you're actually allowed to change your units. And I'm going to do that just to make it easy. I'm actually going to change my units to 1,000 meters. So whenever you see a number, it actually means 1,000 of those. That means I can just put a 1 right here, and that means 1,000 meters. And I need to go from 0 all the way up to 10,000. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so 2, 3, 4, 5, 6, 7, 8, 9, and 10. And again, since I changed my units to 1,000 meters, I can just write these numbers. That's just a quick little workaround to give yourself more space. If you left it at meters, that's fine. You would just have to write out 1,000, 2,000, 3,000, and so on. Okay. Let's look at our range for the y-axis, the force of gravity. Looks like we're going to go from about 1.5 up to 9.8. I'm going to write that down. Range y is going to go from 1.5 to 9.8. Now, if I had given you 10 boxes, that would have been really easy. You could have gone 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's only 8 boxes, so you're going to have to kind of figure out a way to fit these numbers onto this graph paper. So I was playing around with it. I think going up by 1.5 works really well. Let's put a 0 here. That represents 0. And I'm going to make this right here 1.5. And then I'm going to go up by 1.5 again. That's going to make this 3. I'm going to go up by 1.5 again. That's going to make this 4.5, 6, 7.5, 9, and then this should be 10.5, okay? So we've got everything fitting on both axes, and the numbers are consistent as we go up. Next, now we need to plot our points. We're on step 4. We skipped ahead. We actually already did step 5 just to stay organized. We're on step 4. So plot your points. So let's take a look. When we are standing on the Earth's surface, we are 0 feet away from the surface, and at that point, gravity is 9.8 meters per second squared. So at 0 feet, or excuse me, 0 meters, I need to go all the way up to 9.8 and make my mark right about here. Okay. Next, at 1,000 feet away from the Earth's surface, gravity drops to 7.3 meters per second squared. So at 3,000, I need to go to 7.3. That'll be right about here. At 5,000 feet off the Earth's surface, gravity drops to 3.1 meters per second squared. Okay, so at 5,000 feet. Oh, you guys, I screwed up. Let's go back and fix that. I totally screwed up. That's okay. So, 0, it's 9.8. At 1, it's actually 7.3. So that point needs to be here, not here. So at 1, take it to 7.3. Glad I caught that. I bet some of you were like, oh man, he's screwing up. All right, fixed it. Okay, at 3,000, it's 4.5. So now we're down here at 3,000. Okay. At 5,000, the force of gravity is 3.1 meters per second squared. So I'm at 5,000. We go to 3.1. That should be right about here. At 7,000, it's 2.2. Be right about here. And at 9,000, it's 1.7. That'll be right here. And at 10,000, it's 1.5. That'll be right here. All right, everybody. So I've got my points plotted. Okay, we're all set with that. Let's take a look at our 7 components. We've included labels and units. We don't need a key for this graph, and I've given you a good title already, the relationship between distance and gravity. What I did ask you to do is draw that best fit line through your data so we can determine the relationship. So I'm going to take a ruler. Make sure you use a ruler. A lot of people did this without a ruler. Make sure you use a ruler. You're going to do your best to fit all the points into one line, and it should look something like this. Okay, so line it up. Draw that best fit line. Now we interpret the line. As we go from left to right, it looks like we're going downhill. And when we go downhill on a scatter plot, that means we have a negative data relationship. Negative data. Okay, that just means as distance increases away from the surface of the Earth, the force of gravity actually decreases. Okay, so let's take a look at our final question here. As the distance between an object and the surface of a planet increases, the gravitational force on that object decreases. Okay, make sure you get that correct understanding. Distance increases, force of gravity goes down. All right, that's our first graph of the relationship between distance and gravity. Again, make sure you do a best fit line. A couple things. The number one issues that people had in their graphs is that people were not including labels, not including units. They weren't using a ruler. They maybe didn't understand what is dependent on what and then what goes on which axis. And a lot of people were connecting the dots. We don't do that with a scatter plot. That's a line graph. Do not connect the dots with a line. Don't do that. You just draw the best fit line. That's the difference between a scatter plot and a line graph. Okay, good. Next, I've already drawn the graph to make things faster for the second one. The second one is going to be on the relationship between mass and gravity. So I've done this already, and let's just walk through it. So in this situation, there's actually 3 columns, okay? And you're probably like, how do I even start? What do I do? Well, you're going to graph the relationship between the mass of the planet and the force of gravity. We have the different planets here, okay, including the Earth's moon. And so you actually need to make a key to tell the difference between those 4 different objects, okay? And that's how we're going to use a key in this situation. So the planets and the moon go in the key, the mass and the force of gravity get plotted onto the graph. Now in this situation, the force of gravity is dependent on the mass. So I'm going to put force of gravity with our units, meters per second squared, over on the y-axis. And I'm going to put mass, okay, in this interesting little unit here, which just means 1 times 10 to the 24th kilograms. All right, and that's going to be on our x-axis. This 1 times 10 to the 24th, that just allows you to make things smaller. It's called scientific notation. You'll learn that at some point in math and science eventually, but it looks like this. This is what 1 times 10 to the 24th looks like. It just is a 1 with 24 zeros after it, then a decimal point. This is how many kilograms are in each of these. So it just takes a huge number and makes it so you could write it easier, okay? So, again, we're looking at mass versus force of gravity. I've used 4 different colors. For Earth's moon, I've used red. For Mars, I've used blue. For Venus, I've used orange. And for Earth, I've used green. It doesn't matter what color you use as long as it correlates to the correct dot, the correct plot on this graph, okay? So for the Earth's moon, the mass is small, okay? It's smaller than 1. It's very much smaller than 1. It's 0.0735 times 1 times 10 to the 24th kilograms. Okay, so that's going to go way over here close to the 0. And the force of gravity on the surface of the Earth's moon is going to be 1.7 meters per second squared. So close to 0 because the mass is like tiny. And then I go up to 1.7 meters per second squared. This is going to be the Earth's moon. You don't have to write the name of the planet on the graph or the moon because you have it over here in the key. I'm just writing it down to make it very clear. Okay. Now let's do Mars. Mars is also a small mass compared to Venus and Earth. So it's going to have 0.642 times 1 times 10 to the 24th kilograms. Okay, so that dot is going to go right about here. 0.6 is just a little bit more than 0.5, and then I bring it up to the 3.7 meters per second squared. So this right here is Mars. Okay, next, Venus. Venus is much larger than Mars. 4.87 times 1 times 10 to the 24th kilograms is the mass, way out here. So that's going to be 4.87. And then for that mass, the force of gravity on that planet will be 8.8 meters per second squared. So this dot right here in orange represents Venus. And then last, Earth is the most massive of these objects at 5.97 times 1 times 10 to the 24th kilograms. And on the surface of the Earth, the force of gravity is 9.8 meters per second squared. I've used green for that. I plot my point here close to the 6, and I bring it all the way up to 9.8, and I plot the point for Earth. Again, you don't need to write the names on the graph, but I'm just doing it to make sure things are really clear. Once we do that, we take a ruler and we try and fit as many of the dots into one line as we can. It'll look something like that. You draw your line. We have our best fit line. Now, going from left to right, it looks like we're going uphill on this graph, which means we have a positive data relationship. And what that means is that as the mass of the object increases, so does the force of gravity. Okay, so let's look at our final question. As the mass of a planet increases, the gravitational force on that planet's surface also increases. All right, everybody, those are our 2 graphs. Correct them yourself. If you have any questions, please come to study session. Thank you.